Hello friends, my name is Soumen Chatterjee. Today I am going to share the very introductory part of probability theory. So, probability. So, before going to discuss the details about the probability theory, we must need to know why we study probability theory. You know, in our daily life, sometimes, most of the times, we can say the uncertainty. Let's say India-Pakistan match is there. We never say that India will win today or Pakistan will win today. We always say the chances of getting India win today is, let's say, 95% or 90%. Similarly, you tossing a coin, you can't say head appear or tail appear. When you throwing a dice, you can't say 1, 2, 3, 4, 5, 6, what will be appear. So, to solve this kind of uncertainty problems, we using probability theory. So basically, probability theory solve the random types of experiment. Random experiment. What does it mean actually? Random experiment, I can write here, it is an experiment, a random experiment, whose result cannot be predicted in earlier. It is an experiment whose result cannot be predicted earlier. As for examples like, tossing a coin, you can't say head or tail appear. Throwing a dice, 1, 2, 3, 4, what will be appear? In artificial intelligence system, there is plenty of applications of random types, examples of random types of experiment. Then we need to know the sample space. What do we mean by sample space? The set of all possible outcome of an random experiment. The set of all possible outcome of a random experiment are said to be a sample space. First of all, you need to know what is the definition of set. What is set? A set is a well-defined collection of objects. As for example, expensive car. Those cars are expensive whose price more than 50 lakhs. The car whose price more than 60 lakhs, these cars are said to be an expensive. But if you say simply expensive car, what does it mean? You don't have any clear idea what do you mean by expensive car. Another examples like tall man. What do you mean by tall man? So this is not a set because there are ambiguities. You don't have any idea what do you mean by tall man. A man. But when you say a man whose height more than 5.9 feet are treated as a tall man. So then this is a set. Similarly, in probability theory, when you define sample space, the set of all possible outcomes, that means it's a well-defined. As for examples, you can see, suppose you tossing a coin. So sample space basically defined by the symbol capital S. Suppose that is your random experiment, you tossing a coin. So what are the possible outcomes? The possible outcomes are head and tail. Suppose India-Pakistan matches is in cricket match playing there. So what are the possible outcomes? India win, Pakistan loss, or Pakistan win, India loss, or maybe both are draw. India draw and Pakistan also draw. So these are the examples of the sample space. Any kind of random experiment, the all possible outcome. Another examples like throwing a dice. What are the possible outcome? 1, 2, 3, 4, 5, 6. So that is your sample space, right? Okay. Next, event. So what do you mean by event? Any subset of an sample space is said to be said to be an event. What does it mean? First of all, you need to know what is subset. Suppose you have a set, let's say A is equal to 1, 2, 3. So what are the subset? Then subsets of A, you can write 5. 5, what is 5? 5 is a null set which doesn't contain any element. Then 1 itself a subset, 2 itself a subset, 3 itself a subset, 1, 2, 1, 3, 2, 3, and finally 1, 2, 3. So these are the following are the subset of that particular set. So if you have in a set, if you have n elements, then how many number of subset do you have? 2 to the power n. Simply you can see here the number of element contained in a set A, the total number of subset 1, 2, 3, 4, 5, 6, 7, 8. So 2 cube. So these are the subset of that particular set. So similarly, what is even in probability theory, suppose you just throwing a dice. So what are the sample space? Your sample space contain 1, 2, 3, 4, 5, 6. Then what is your event? Normally event can be defined by the symbol like A, B, capital letter A, B, C, D, like this way. So suppose here A is an event, you can write 1 simply. Or let's say B be an event getting even phase. Even phase means 2, 4, 6. Let's say C be an event getting, you can say odd phase. So 1, 3, 5. D be an event getting multiple of 2, again 2, 4, 6. And E be an event getting 8. Let's say 8. But if you see here this sample space doesn't contain 8. That means it contains only null set. So that is your event. Clear? Okay. So next. Okay. So next you need to have some idea about union. What do you mean by union? Union basically defined by the symbol U. Its logical operator or arithmetic operator is plus. So what is union? Union means the addition. We should integrate together. Or union means something addition. Let's say, as for examples, let's say you have 2 sets. Let's say 1, 2, 3, and you have another set. Let's say 3, 4, 5, 6. So then what is the value of A union B? You just add them. Let's say 1, 2, 3, 4, 5, 6. So that is your union. You need to remember, if the element 3 and 3, here you can see, repeat, then you just write on a single times in that case of union. So union, you need to remember, in probability theory it's very, very important when you're doing some problem, some mathematical problem. If the concept is behind it is like OR concept, A or B, then you must put union there. And another one is called intersection. Intersection means common. Its symbol, it looks like that. This is your symbol. Its logical operator is AND operator, and its notation is multiplication. So intersection means the common element between 2 points. So if you do here, let's say in that particular examples, here A intersection B. So what is the common point here? 3. Here also 3. So you could write here 3. So that is called intersection. Clear? And its operator is AND. A and B. Then you put it here, intersection sign. Okay. Next. Next is how to calculate the probability of an event. It's a very, very important. So that is your axiomatic definition basically. So probability of any event P of A, that is equal to, you can write N of A by N of S. And P of A always must be greater than equal to 0. I will show you later what is the value of P. Basically it lies between 0 to 1 and why. Let's see. So first, P of A, that is equal to N of A by N of S. What does it mean? N of A means number of sample point in event space whole divided by number of sample point in sample space. number of sample point in event space by number of sample point in sample space. As for examples, let's say, very simple example. You tossing a coin. So what are the sample space? 8 and 10. So these are the possible outcome. Let's say A be an event getting head. So A contain head. Then what is the probability if you tossing a coin? Then what is the probability getting head? So what is your answer? Your formula is n of A by n of S. So n of A means how many points do you have? These are called sample point. How many points do you have in A? 1. And how many points do you have in a sample space? 2. 1, 2. So what is your required probability? 1 by 2. Another examples like, is it clear? Okay, so another examples like throwing a dice. So what are the possible outcome? 1, 2, 3, 4, 5, 6. Suppose A be an event getting odd phase. That means 1, 3, 5. So what is the probability getting odd phase? The question is, you throwing a dice, then what is the probability getting odd phase? So how to do this? It's a very simple. P of A is equal to n of A by n of S. So n of A means here. So what is the value of n of A? N of A is equal to 3. And what is the value of n of S? Equal to 6. So what is your answer? 1 by 2. Okay, so it's clear. Now I will show you the probability of any event always lies between 0 to 1. How? Here A is an event of S. So that means A is a subset of S. That means that is your sample space. That is your sample space. Event means event always lies inside the sample space. That is your A. So that means those elements are belongs to A. That means it implies also belongs to A. So A is a sub. Then you can say, okay, A is a subset of S. I already shown you the subset. Let's say here S is equal to, let's say 1, 2, 3. So what are the subset? Subset is like null set 5, 1, 2, 3, then 1, 2, 1, 3, 2, 3, and finally 1, 2, 3. So what are the minimum values of that particular subset? 5. And what is the maximum element in a subset? That is 1, 2, 3. That means S. So A, when A is minimum, so A is minimum, n of A is minimum when n or A is equal to 5. N of A, that means number of sample point in event space, is minimum when A is equal to 5. So then P of A, its mean value when A is equal to 5. So if you put n A equals to 5, so n of 5 by n of S. 5 means null set, it doesn't contain element. So that is equal to 0 divided by n of S. So what is the value here? 0. And now, so this is a single case. I will put it, let's say this put. So therefore here you will get P of 5 is equal to 0. Now A maximum, P of A max value, when it is maximum? When A is equal to S. That means when A is equal to 1, 2, 3. That means every set itself a subset. That's why when A is equal to S, then its value is maximum. So then its value you can put n of S, you just put A equal to S, you will get n of S by n of S is equal to 1. So therefore P of S is equal to 1. So that's the equation number 2. Let's say this is your equation number 1. Except these two cases, I mean except maximum or minimum, other cases you will find always n of A is less than n of S. Because I already shown you the examples, let's say 1, 2. So what are the events? Subset of S. Subset of S is given you 5, null set, 1, 2 and 1, 2. So I already take this case and that case. So this is your null and that is your 1, 2. That is maximum, which is equal to S. Except these two cases, you can see here n of S is equal to n of A is equal to 1, subset of A is, I just put it here, A, named is A, 1, n of this equal to also 1. So except other cases, n of A is less than n of S. In that case, P of A is equal to n of A by n of S must be less than 1, but it has some values, so greater than 0. So this here put number of 3. It has some values greater than 0 means a number cannot be negative. You can't say, okay, there are -2 types. You can't never say it. So that's why it's greater than 0, but n of A is less than n of S. So denominator term is much higher than numerator term, so it's less than 1. So from 1 to 3, once we can conclude that P of A always lies between 0 to 1. You can see here 0, here greater than 0, so you can put greater than equal to less than equal to 0. Then P of A is 1, here less than 1, so less than equal to 1. So this is a very important result for probability theory, axiomatic definition probability theory, and it satisfies this result. P of A always lies between 0 to 1. So clear? Okay, now event. So there are, we will discuss about the different types of event. Basically, events, there are 3 types of event mainly. Plenty of event, but most importantly 3 types of. First one is mutually exclusive or mutually exclusive. Second one is exhaustive, and third one is independent. What do you mean by mutually exclusive? 2 events A and B are said to be mutually exclusive if their intersection gives you null phi. Then these 2 events A and B are said to be mutually exclusive event. As for examples, let's say throwing a dice 1, 2, 3, 4, 5, 6. So these are our sample space. Let's say A be an event getting odd phase. Let's say 1, 3, 5, or B is equal to, let's say something 2 and 4. Then what is the value of A intersection B? You will get nothing common in between them, A and B, nothing common, so it's null. Then you can say, okay, these 2 events are mutually exclusive event. Exhaustive event. What do you mean by exhaustive event? If the union of 2 events gives you the whole sample spaces. If you see clearly here A is equal to 1, 2, 3 and B is equal to 2, 4. If you union them, A union B, you will get 1, 2, 3, 4, 5, but not 6 here. So again, these 2 events are not exhaustive. But if you take the event, let's say throwing a dice, for dice problem, I just put it here, for dice problem, let's say A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 6. Then what is the value of A union B? You will get 1, 2, 3, 4, 5, 6. So 4 repeated both the event A and B, so we just write in a single time and you will get it. Okay, so then these 2 events are said to be an exhaustive event. And last one is independent. What do you mean by independent? P of A intersection B is equals to P of A into P of B. Then this event are said to be an independent event. As for example, suppose A is equal to, let's say 1, 2, 3 and B is equal to 3, 4. Then A intersection B contain only 3. Then what is the value of P of A? P of A is equal to 3 by 6, that means 1 by 2. What is the value of P of B? 2 by 6, that is equal to 1 by 3. And what is the value of P of A intersection B? Is equal to intersection B contain only one element, so 1 by 6. If you see P of A intersection B is equal to 1 by 6, so here if you multiply them, P of A into P of B, that means 1 by 2 into 1 by 3, you will get P of A intersection B. So then these events are said to be an independent event. So basically, so these are the events. It's a very you need to remember. Mainly there are 3 types of events: mutually exclusive, exhaustive and independent. What do you mean by exclusive event? If A intersection B is equal to 5, that means two events are said to be an independent exclusive event if there is nothing common between two events. That means their intersection will be 5. So then these two events are said to be mutually exclusive. Exhaustive event, when you union these two events, you will get the whole sample space S. Then you will get, this is your exhaustive event. As for example, I will show you A is equal to, let's say, throwing a dice, A is equal to 1, 2, 3. That means you will get odd phase, and B is equal to, you will get even phase 2, 4, 6. If you add them, union them, then you will get 1, 2, 3, 4, 5, 6. That means you will get whole sample space. Then these events are said to be an exhaustive event. And finally, independent. What do you mean by independent event? If P of A intersection B is equal to P of A into P of B. That means probability of A intersection B. Let's take an example. Toss throwing a dice. So let's say you're getting 1, 2, 3, and B, these are even getting 3 and 4. Then what is the value of A intersection B? A intersection B is 3 is common here, so 3. And what is the value of P of A? P of A is equal to 3 by 6, so half. And what is the value of P of B? Again 2 element here, so 2 by 6, because in a throwing a dice here N of S is equal to 6. Here you can find N of S equal to 6. So here also 6 by 6, and N of B is equal to here only 2 elements, so 2 by 6, that is equal to 1 by 3. And finally A intersection B, here contain only one element. A intersection B, how to calculate? Now P of A intersection B is equal to, you can write N of A intersection B by N of S. So N of intersection B means 1, so 1 by 6 here. So now P of A into P of B, you will get 1 by 2 into 1 by 3, that is equal to 1 by 6. So finally you will get A intersection B is equal to P of A into P of B. That means these two events are independent event. Okay? Okay, so hello friends, if you have any doubt or query for today's lecture, please put a comment in a comment box, and in next lecture I will discuss more about let's say events regarding or probability, some theory. We will discuss on what is the probability for any two arbitrary events A and B, then what is the value of P of A union B, what is complement event. In my next lecture I will discuss this. So thank you.